I'm Beth Wilson. I'm one of the hosts of STEM in 30, a television program produced at the National Air and Space Museum for middle school students. Welcome to today's live chat. We're going to be talking all about astronomy that you can do at home. Our first STEM in 30 episode for the 2021-2022 school year was just released last week. We tried to explain rotate and revolve, and we had a little help from the world famous Harlem Globetrotters. Let's check this out.
Hey everybody, I'm Julian Zeus McClurkin of the world famous Harlem Globetrotters. Let's imagine for a second that this basketball is Earth. It spins on its axis, an imaginary line running down the middle. This is called rotate. Earth rotates on its axis like this. And this is Darnell Speedy Artist with our moon. The man on the moon. The moon spins on its axis. It's rotating just like the Earth. The moon spins a lot slower than the Earth, but we're gonna do it faster because it's just way more fun that way. Not only is the moon rotating, it also orbits or revolves around the Earth. That means it goes around the Earth. Fell off the axis. Time to get a little more complex. Look over here at the sun. The Earth revolves around the sun. All the while, it's still rotating and the moon is rotating on its axis and orbiting around the Earth at the same time. That means the whole cosmic neighborhood is moving. All of this moving, rotating, and orbiting, that affects what we can see in the night sky.
So remember, spinning on the axis is rotating.
Moving around an object, that's called revolving. See?
And this is out of this world.
Ha!
We want to remind you that we will be taking questions live from the audience. Put them in the comment section and we'll get to as many of them as we can today. Also, let us know where you're watching from and we'll give you a shout out. To help me answer your questions today is Shauna Edson, who is an astronomy educator at the National Air and Space Museum. Shauna, thanks so much for joining us again.
Thanks for having me back. You know, I love this.
I know you do. Shauna, let's start with the basics. Who and how for astronomy?
All right, I love that. So the who is literally anybody who's interested. Astronomy is for everyone. The sky belongs to everyone. And the how is not as complicated as many people think, but there's a better experience to be had if you do a little preparation. So a lot of times it seems like astronomers just magically know what's in the sky and walk outside and know where everything is. And in truth, we kind of make it look that way because we've done some preparation. So there's the where are you going to be looking or observing from? So finding a good spot where you can see the sky, you don't have too many things in your way, and you don't have any bright lights right above you. So that means you don't have to go to a dark place far away from a city. You can do sky gazing from wherever you live. You just want to kind of place yourself so there's not, a street light or something right in your eyes. But anywhere that you can see the sky that is safe for you is a great place to observe or view the sky. And then figuring out what you want to see, there's a number of resources that can help you know what is in the sky so you know what to look for and where to look for it in the sky. So finding your place, finding sort of what is out there to see, having a few things with you, which could include a star map or a star app, some warm layers because it tends to get cool once the sun goes down, and just a sense of curiosity are good things to have with you.
You all have been running some really cool online planetarium programs, and we're going to get to those in a minute. We're going to let you run your planetarium show for us. But I want to remind everybody that we will be taking questions, and Shauna would love to talk about what is on the screen. She loves
Questions
a
are my
lot of interaction.
favorite part of this. It's
So
kind of a
please,
choose your own adventure because for all of the planetarium shows we've been doing since this January, we have kind of a framework. There's some things that we can show and some points that we like to hit. But I always really love to know what you, the audience, are interested in, what you want to know how to find, or if there's something you have seen in the sky where you're wondering what it is or how to figure out what it is. So any questions like that, anything about space, I love that because that makes the planetarium show different every time, and that makes it more interesting for me.
well, Shauna, you already got a shout out from Megan who says you are amazing. Great job. We are always stargazing from Alaska, so maybe we can take a look at an Alaskan sky.
Oh, that's so awesome because yeah, in Alaska, the North Star's closer to overhead, and you might even be able to see auroras. That is super exciting.
Well, let's start with your planetarium program. And
Yes.
Megan, hang on, and we'll try and get to Alaska during this.
Yeah, I can absolutely show the sky from Alaska. So when we do these planetarium shows, we're using a software called Stellarium. And you can find it at stellarium.org. It is a free program. There's a web version and a downloaded version, but it is free and it's really powerful. And this is the kind of tool that every astronomer I know uses to help plan what they want to look for because it's a model. So it shows I've got us in Washington, D.C., which is where I am, but you can choose any location on Earth and you can actually go to other planets or places in the solar system. The stars won't look different if you go to another planet. The locations of the other planets and the sun will change, but anywhere on Earth you can see the different constellations. So you can choose your location. You can also choose the date and time. So I've got 9/9, which is today, September 9th, and I've got the time. It's in 24 hours. So 18 is about is 6:45. There we go. I had to think about that. So I'm showing the sky from Washington D.C. at about 6:45 tonight. So I've got the sun getting ready to set. And you all may have noticed these letters on the bottom, those are the directions. So this is the west, and the sun is setting in the west. I can pan the view so I can change where we're looking. We've got sort of a picture of a grassy field that just shows us where the ground is so we know which way is down or up. And I love that Globetrotters video because the revolution and rotation, the words can get confusing. I tend to say orbit instead of revolve so that it's not as confusing. But one of the things about living on the Earth, which is a rotating planet, is that the things in our sky will move. So I'm going to take us back a few hours. So this is about 3:45. I'm going to set time going forward. We have the sun and the moon, and they're moving through the sky. And it's very easy standing here on the ground to see these things moving and to perceive them as those objects moving through the sky. But as the Globetrotters just showed us, because we're standing on the Earth and it's rotating and we're rotating with it, much the same way that I'm in my chair and I spin, here's my screen, here's all of you. And if I spin this way, it looks to me like you went that way. But in truth, you haven't moved, I've rotated. So as the Earth rotates, the sun, the moon, the stars, everything in the sky will move across. And so that's how we get our sunrises and sunsets. And this is the view of what we will see tonight. So we have the sun setting, and I'll take us a little deeper into the night. And then as it gets dark, as soon as it gets dark, it gets a little easier to see the moon. And it's this nice little skinny crescent. So the sun is just shining on sort of the back part of it. So we just see that little part of it that's lit up. And then you notice this really bright thing next to it. And I would love to know if there are any guesses as to what that is. Beth, do you know what it is?
I do know what it is. I know that it's a planet, correct?
Mm-hmm. It
Uh,
is.
and Give us 1 second to see if we can get some guesses coming in.
Yeah.
And while we're waiting for those guesses to come in, we have put the Stellarium link into the chat.
Yes.
So if you all want to go ahead and try this out at home, you can find the link in the chat. We've got some people thinking since it's a planet, a lot of Jupiter's coming in.
Okay. Really
Uh,
good guess. Yeah. Yeah.
because it's big and it's bright. Other people, Saturn. I think Saturn's a little too far away. That's what we've got coming in so far.
Awesome. Yeah. And
So those
Beth
are a
probably
couple of.
knew it was a planet because it's really bright. It is not twinkling, and it is in the same path as the sun and the moon. So we saw the sun and the moon kind of moving this way through the sky, and this planet is in a similar path through the sky. So those are the three rules for looking for whether something is a planet. And I will throw on the label.
Someone thinks it's Venus.
All right. So we've got Venus, Jupiter, and Saturn.
Mm-hmm.
All excellent guesses. Well, big reveal. That would be Venus.
Okay.
And Mercury happens to be in the sky here. I don't think we're going to be able to see it all that well. Mercury's not super bright. Because Mercury and Venus are the closest to the sun, they orbit closer to the sun than we do. As the sun goes through the sky, Mercury and Venus in their orbits, they can never be very far from the sun. So we'll only ever see them above the sunset or the sunrise. And Mercury's orbit is so small, it'll be visible for maybe a week and then it'll go away. But yeah, this really bright one that's going to be right next to the moon tonight is Venus. And so I was skipping ahead by hours a second ago. I'm going to skip ahead by a day now. So the next day, all right, so the moon has moved because the moon moves through the sky as it is revolving or orbiting around the Earth. It'll change where it appears in our sky. And if I jump ahead another day.
Okay, Shauna, we've got a question.
Yeah.
Someone would like to know if these are going to stay, how long these are all going to stay lined up, the moon, Venus, and Mercury.
Yeah, so that's a really great observation. Yeah. So all of the planets in our sky follow the same path as the sun and the moon. And one of the awesome things I can do in Stellarium is pull up a marking called the ecliptic. The ecliptic is technically it is the path of the sun through the sky, but it's really it's where all the things in our solar system move. So the sun is in the center of our solar system, solar, sun, all the planets and asteroids and comets and other things are orbiting around it. They're all pretty much flat. They're not kind of going in all these different directions. They're all mostly orbiting in this flat plane. So the solar system is kind of shaped like a big pizza. And from the Earth, all of the things in that pizza really seem to follow along this line.
Now, somebody's just stated that they saw a planet with their naked eyes a few weeks ago, and had no idea which one it was. I'm thinking you're going to help us out with that.
Well, okay, so that's exactly the kind of thing where it's a great thing to notice and wonder about. And software like Stellarium is one of the best ways to answer it. So the question I would pose to you is, we're here in the west, so we can see this glow. The west is where the sun has disappeared. So in the west, it's bright as the sun is setting and the twilight is fading. So the planet that you saw, was it close to the sunset, or was it over here on the other side of the sky? So those of you who were guessing Jupiter and Saturn earlier, they are up in the sky. They're just a little more over to the east. So Jupiter is really, really bright. Saturn's not quite as bright, but it is brighter than most of the stars. And you'll notice they all fall along this ecliptic line. So that's just because all of the planets in our solar system orbit along that plane. This is this line through the sky. And in the real sky, you can't paint a line. But if over the course of a day, you just kind of notice, where does the sun rise, where you're looking from, where does it go in the middle of the day? So right about now, it's 1 o'clock on the East Coast. This is around the time when the sun's the highest. So that'll be roughly south if you're in the Northern Hemisphere. And then at the end of the day, it'll be in the west. So if you notice kind of where the sun goes through the sky, that traces out this ecliptic line, and then it shows you where to look for planets. So the planets change where they are in our sky because they are moving around in their orbits. So if I skip ahead a day or so at a time, it's still the same time, so it's about 7:30 at night, a little after sunset. But as I go, you'll notice the planets are kind of scooting along here. The Venus is kind of shifting. And I don't know if any of you remember back in December, we were all really excited about the Great Conjunction when Saturn and Jupiter were really, really close together. So now we see they're separated in the sky. So as they've moved in their orbits, they've shifted where they are in the sky. So that motion means that the number of planets we can see in the evening sky will change. So how many of them are in a line like that will change. There have been times when all 5 of the visible planets, so there's 5 that we can see with just our eyes. So we've got Mercury, Venus, Jupiter, and Saturn here. Mars is the other one. I believe Mars is ahead of the sun. Actually, maybe.
Shauna, we've got a couple of reminders. I want to remind everyone to keep asking questions.
Yes.
If you're liking this broadcast, please share it so more of you can join the conversation. And we have a follow-up from our friends who saw the planet a few weeks ago,
Uh-huh.
and they had no idea. It was closer to the moon after sunset, and they're looking up from Stamford, Connecticut.
All right, so Connecticut sky is going to be about the same as what I see here. Depending, your time zone isn't really going to make that much difference. It might shift by about an hour, but no matter where you are, sort of east to west on the Earth, what you see after your sunset each day will look kind of the same no matter where you are. The thing that will change what you see in the sky and kind of how high things are or which constellations you see, that difference will be how far north or south you live. So our friends in Alaska, who are much farther north than where I am, will see the North Star, sort of those northern hemisphere constellations really well, but there will be some stars that are farther south that are below their horizon that they can't see. If we were down near the equator, we would really be able to see almost the entire sky. That you're sort of right in the middle of the Earth, so you can see almost to the North Star and almost to the South Pole. So our friends at the equator can see almost every constellation. And then for our friends in the southern hemisphere, so Australia, New Zealand, southern parts of Africa, and South America, there are constellations that they can see that we can't see at all because they're looking at just a different part of the sky. But because the Earth rotates, eventually all the parts of our north or south chunk of the sky will pass through our view. That'll just change with the time of year.
I think you might have answered this question a bit, but we've got a viewer who would like to know which planets can we see with the naked eye? And I think that what you're saying is it depends on where you are.
Yeah. So if you live really far north or south, so if you're close to the North Pole or the South Pole, there will be times of year when it's really hard to see planets. They'll be very low on the horizon. And that's because if you're close to the North Pole, our whole Earth is tilted, which is why we have seasons. So if you're on the, you know what, I'm just going to use my globe for this. So if you're up on the North Pole and the sun is over here, your part of the Earth is tilted away from the sun. So all the planets and stuff are kind of down here. So if you're tilted away, the planets and those things are going to be low. And there are even parts of the Earth in what we call the Arctic Circle where they're tilted far enough away that in the middle of winter, the sun just never rises. It's just dark 24 hours a day. At the same time, our friends in the southern hemisphere are tilted toward the sun. And in the Antarctic Circle, the sun is up all day. So you can get midnight sun. And then at the other time of year, the northern part of the Earth is tilted toward the sun and they get midnight sun. Alaska is known as the land of the midnight sun. So when it's sunny all the time, you won't be able to see the planets because the sky's always bright. And when it's winter and you're tilted away, the planets may be really low in the sky or just not up at all. But over the course of a year, the planets will actually just over the course of time, the planets will change kind of where they are in the sky. They can be up at different times of year. But the planets, which planets are up when, will change every single year because their orbits are on different time periods. The constellations and stars will see the same ones at the same time of year every year.
We have a question also, which I think is interesting. How can you spot the North Star if you don't have an electronic device handy? I'm sure
Oh,
you're looking at that long before our smartphones came about.
yeah. So I've been mentioning the North Star, and I'm glad you asked that because the North Star is a really important star, and it is in the north, as you would imagine. And the reason it's special is it's not super bright. It's definitely not the brightest star in our sky. I'm going to set the sun a little farther. There we go. All right. So we have our N. We're looking north. And the North Star is special because it is exactly above the Earth's North Pole. So when the Globetrotters were talking about rotating on an axis, that imaginary line that goes through the Earth that it spins around, if you were standing right at the top of the Earth at the North Pole where it is spinning and you looked straight up, the North Star is what you would see. So it happens to be right above our North Pole. And what that means is that as the whole sky appears to rotate as the Earth rotates, the North Star doesn't move. So I'm going to fast forward time here.
While you're fast
So
forwarding
the
time,
whole sky's
I'm gonna
rotating.
I'm going to say hello to Karen, who's in South Carolina, and Tim with grandson is watching in Owen, or grandson Owen is watching. They are watching in Pennsylvania. So
Oh,
find us the
awesome.
North Star there.
Yeah. Yeah. So anyone who lives north of the equator, anywhere in the northern half of the Earth, you'll be able to see the North Star. So I've been showing, oh, we made it all the way to morning. So I've been showing the sky rotating, and hopefully you've noticed that all of the stars were moving except for this one. So I'm going to take us back to the evenings. We're not in the middle of the morning. All right. So it is called Polaris because it's the pole star. And you can find it a couple of ways. So it is the end of the handle of the Little Dipper. But the Little Dipper doesn't have a whole lot of bright stars. There's the two kind of at the end of it here and this one. From where I live in the suburbs, I can find the North Star and these two. I really can't see the rest of them. The North Star is generally bright enough to be able to see from a city, but just kind of looking for it can be a little tricky. If the sun has set, so remember the sun set in the west over here. If you want to at least get yourself facing north, you remember kind of where the sun had set and you get that direction so it's to your left. If the sunset was off to your left, then where you're looking will be roughly north. And then once you've found that north direction, what you want to look for is the Big Dipper, which is down here. So the Big Dipper has 7 pretty bright stars. I can usually find all of these, maybe not this one, but all the rest of these I can find from the bright area where I live. And the trick to finding the North Star is to use these 2 stars. This is something astronomers do all the time. There are 88 constellations in the entire sky that astronomers use, and I don't know anyone who's memorized them all. We start by learning a few, and then we do what's called star hopping. So you use bright stars in a constellation that's easy to find, and then they point you to other things. So the 2 stars here, if we've got the handle and the bowl of the Big Dipper, sort of a big spoon. I know in some parts of the world it's known as a plow or a wheelbarrow. I learned it as the Big Dipper. So these 2 stars on the end of the bowl here, you don't need to remember their names, but this one is Merak and this one is Dubhe. And they make a line. And if you continue that line, the first bright star you get to is the North Star. I like to say Merak, Dubhe, and Dubhe, 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 do. Because you go about that same distance, Dubhe, 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 do. And there we are. We are at Polaris. So sunset on your left, find the Big Dipper, follow those 2 stars to the next bright star, and it will be Polaris. The farther north you live, the higher it will be in the sky.
And if you can't remember all of that, on our STEM in 30 episode, we do have a great animation on star hopping. So I highly recommend everybody go ahead and check that out. We have time for one last question. First of all, we have Michigan is watching. They're checking in on YouTube. So people want to know if the Stellarium, that will it show all of the constellations from everywhere in the world?
It will. So here's Washington, D.C. So we've got Vega, Deneb, and Altair, which make the summer triangle. If I put the asterism lines on, here's the summer triangle that I love. But we can go, so in location, I can decide that we're going to go to, if I can spell it, Sydney, Australia, which is on the other side of the world. So it's daytime right now. But if I set the sun, so now we have a few familiar constellations. So Scorpius is one that we can see from here. Sagittarius, kind of the teapot. But then we get down into Gros, which I think is a goose. Let me put on the artwork. And then there's Phoenix. I love the Phoenix one. There's Centaurus, which is cool. So Centaur is a half human, half horse. These 2 bright stars, this really bright star in the front here, that is Alpha Centauri. That is the closest star to the sun. So the next closest star in the sky, a lot of these stars are hundreds or even thousands of light years away. But Alpha Centauri is our next closest stellar neighbor. It's only about 4.5 light years away. And then down here, Crux, this is the Southern Cross. This is probably the Southern Hemisphere constellation that the most people have heard about. So yeah, so this Stellarium program, it has this artwork to show kind of what people might have imagined these constellations looked like. And it can label them. So here is the sky from the Southern Hemisphere. So you can go to any place on the Earth. Most of the main cities are in the database. And you can find out what the sky looks like now. You can find out what it'll look like in a few months. And you can label the constellations. There are even different constellation schemes. So this is the 88 constellations that scientists use that were agreed upon by the International Astronomical Union. But there are a number of other, there are as many ways to understand the sky as there are peoples and cultures around the world. And so under star lore, there are a whole host of different star schemes, and not all of them have artwork with them. But depending, okay, so we do have, so there's like this hook. So this is what I know as the tail of Scorpius the Scorpion. But now I think this one is a boat. So you can explore some of these different ways of understanding the sky. Western is the one that is the 88 that the scientists use, but this can be a great way if you're curious about constellations and ways of knowing the sky that have been developed all around the world. You can look for that. You can also go backward and forward in time, and not just months or years. This program can go up to 100,000 years into the past or future. So I can do 99,000. And you'll notice all the lines connecting the constellations kind of look sort of tangled, because in 100,000 years' time, a lot of the stars have moved. They've changed position as all the sun and all the stars are orbiting around the center of our Milky Way. They've shifted. So in our lifetime, the constellations will stay the same. But on the order of thousands of years, the stars will shift and those constellations will change. Yeah.
Well, that is all the time we have for today. I hope that everybody takes a moment to check out Stellarium. But before we leave you today, there are a couple things that I want to go over. First, both the National Air and Space Museums are open, the Downtown Museum and the Stephen F. Udvar-Hazy Center, if you get a chance to come out and visit us. The the observatory downtown is also open. But Shauna, you guys are doing some cool things online as well.
Yes. So every month we have had Soar Together sort of family days, and September's is about astronomy. So next weekend, the 17th and 18th, there will be, we will launch our Astronomy Soar Together, which is all a bunch of activities and events you can attend and things you can do to help get you prepared to stargaze, all the things I was talking about at the beginning. So that will include a virtual planetarium show that I'll be running in Stellarium on Saturday the 18th. There are also some virtual story times. There are some sort of anytime activities that you can do that help you get ready to view the sky. And we invite you to check out all of that. It is on the Air and Space Museum website.
Also, STEM in 30 just released our latest episode, which was focused on astronomy that you can do at home. In it, you will see some awesome new animations on astronomy. And we even have a way for you to make your own moon phases board at home.
Yes.
Upcoming next month, STEM in 30 looks at advancements and innovation technology, specifically dealing with mail delivery. So if you're interested in that, it really is a fascinating show. We teamed up with our friends at the National Postal Museum. We will also host a live chat that I'm really looking forward to. It's a Wikipedia edit-a-thon. Be sure to check that out. And if you enjoyed this program, be sure to follow STEM in 30 on Facebook and Twitter, and subscribe to the National Air and Space Museum's YouTube channel. I want to thank you all for watching today, and we hope to see you again soon. Take care.